at this point, we have worked our way to what I've termed the filaments. And these filaments are making up the parts of a cell, also known as a fiber. And we've learned that we are looking at these filaments in what we term a sarcomere. And the sarcomere is the functional unit of skeletal muscle. Now, let's go back just for a minute and let's review our structures that we're looking at. When we look at a sarcomere, basically, if we're looking at a muscle cell, remember, we're looking at something that has a long length to it. It's tubular in structure, and we had all those striations that were present. And from one to one to another to another, so if we go from here to here to here to here to here to here to here, and so forth, every single one of these is going to be a sarcomere. Okay? So, if we think about that muscle fiber, and the job of the skeletal muscle is to make sure that we contract and then relax, it's going to become the job of that one sarcomere, this one, this one, this one, so forth, okay, to shorten. Because if it can shorten, it's going to contract. Now, once again, in relaxation, it's got to unshorten. Okay? So, one of the things that I mentioned, muscle is not going to contract without the nervous system. So we're going to have the nervous system be the reason that muscle is going to contract. So we're going to find that for every single muscle cell, all right, which is part of a bundle, just kind of all bundled together, okay, and then we would have bundles bundled together, making that muscle, all right? So that means for every single one of them, they're going to have a connection to their nerve supply, all right? So that means every single fiber is going to have a nerve and its terminal bud that innervates it. But it only innervates it at a point. In other words, we don't have innervation along this entire muscle fiber. Okay, is everybody with me? Now, going back to our structure of this, when we've got the thin filaments, okay, and we've got the thick, remember that on the thin, we've got our tropomyosin, troponin, this little double helix of the globes, which are going to be the actin. They are going to have an active site. On that thick filament, the myosin, we've got what looks like golf clubs, okay? The only difference is it looks like the end has the two heads rather than one to play golf. So, the trick, how am I going to get this myosin head to interact with one of these active sites? Okay, that's going to be the biggest trick that we've got to do. So, what we're going to find, we're going to have the thin filament, the active, with an active site, that double helix, okay? The structure that's making it up, the way that we've got the tropomyosin, which looks like a rope, okay, that's going around that double helix. And then each time we have that double helix come to where it looks like it twists and starts all over again, we're going to find those little 3 molecules, those little 3 units, I should say, those 3 units of the troponin. Now, the tropomyosin, the rope, and the 3 units, they form a complex, something that we call the tropomyosin-troponin complex. Look at what it does. Regulates the interactions between the active sites and the myosin head. Wonder how that's going to happen. All right. So if we think, and once again for right now, let's think about the structures. Okay. The structures. What we're going to have to see is that we're going to have to get these active sites to be available. So if I have this thin filament and I've got this rope that's wrapping around it, and at each little pinched in area, y'all know what I mean by the pinched in area, right? Where it looks like it's kind of doing the helix shape, okay? I've got this little 3 subunit thing, okay? So I've got my troponin and my tropomyosin. Now note, this picture right here, it looks like it's covering all of my active sites, okay? Now, these myosin heads, the goal is to make sure that I can get these myosin heads to attach to one of these active sites. But wait a minute, they're kind of covered up right now. Those active sites are covered up. Those myosin heads, if I can get them to attach to one of those active sites, they're going to form what we term a cross bridge. So if that myosin head can fit into one of those active sites as it attaches, and the way that it will attach, we term it a cross bridge. Because don't forget, I got one myosin head in this direction, one in this direction. So that tells me that myosin head to that one golf club, okay, can attach to 2 actins. Does that make sense? Because I had that thick myosin surrounded by those thin actins on each end. But now I got this tropomyosin and troponin complex, and that's kind of in my way for that to happen. Now, what we're going to see, we're going to have that head be able to attach and release, all right? A couple of things are going to have to take place. We need some ATPase, which is an enzyme. The enzyme's job is to usually break something apart, help it, build it up, break it down, something to that effect, right? What is it going to act on? Remember, the ASE of the term of an enzyme is always telling you what it's going to act on. So the ASE on that term right there, what is it acting on? ATP. ATP is what? Our energy molecule. So now it's telling me that the ATPase is going to get broken down because ATP is telling me that it has 3 phosphates. And in order for me to get the energy, I need one of those phosphates, right? To turn it into ADP. So this is going to happen, all right? So what we're going to find that myosin had, for it to do its job, it's going to require energy from that ATP. So, what's going to happen? All right. So, if we think about all the parts of that sarcomere, which is the functional unit, I've got my Z discs, okay? And I've got my thick filament, my myosin. It's surrounded by the thin filaments, the actin, all right? It has a point that goes straight down through the middle that is called the M line, all right? Our Z discs, that's the boundary of our sarcomere. My goal, okay, when we look at the striation that we have in a muscle cell, muscle fiber, we're going to see that the striation is there because we've got overlapping that's taking place. I've got some overlap between my thick and my thin. I've got some distance with the Z disc. I've got some distance in this M line. I'm not asking you to know everything, okay? But the goal, okay? The goal. Make sure that these Z discs, by way of my thick and my thin, can pull together. In other words, so that my thin filaments can move towards the M line, towards the middle. And if I can get that to happen, if I can get this to shorten up, contraction has taken place. And if I can get enough sarcomeres and enough fibers to do this, then my muscle is going to contract. Okay? In the structure, you guys, Linda?
Let's talk about some ways that you said something overlaps, and that's what we see as vibration. Is it sarcomeres or sarcomeres or Z?
Yeah, when you look at the striated appearance of that muscle cell, and the reason that we have the striated appearance is because of this structure in the sarcomere. So, if we look at the structure that we have, from here to here is a sarcomere. So all of these different colors that are showing up right here, those are our main paths. Like this is our M line, this is our Z disc. We're going to have the H zone and so forth in this one sarcomere. So from here to here is one sarcomere. Okay? From here to here is one sarcomere. From here to here is one sarcomere. From here to here. From here to here. That's one sarcomere. From here to here. That's one sarcomere. From here to here. That's one sarcomere. Let me make sure I get it on camera. So from here to here, that distance in between, that's one sarcomere. And it has, do you see how it's got like a lighter color, darker color? Okay, this is supposed to be representing the thick filament, the thin filaments. Okay, so that would give the difference in the appearance, if that makes sense. Okay, so my goal is to make sure that I get those two Z lines, okay, those two Z discs, and get them to shorten. And if I can get this one to do it, this one to do it, this one to do it, and so forth, then the entire muscle is going to go, which is contraction. Okay?